Today, we're diving into the incredible, invisible systems that literally keep our world running. It's a technology called predictive maintenance, a really smart combination of AI and sensors that basically gives machines a voice that can warn us right before they're about to break. But to really get why this is so important, let's start with a question. Just imagine a massive, high-stakes factory, say one making life-saving medicine. What do you think is the real cost when just one critical machine suddenly goes down without any warning? It's way more than just a simple delay. So let's really unpack that. In a world as tightly regulated and as crucial as pharmaceuticals, a machine failure isn't just a headache. No, it's a full-blown crisis. I mean, look at this. A single failure can trigger a catastrophic chain reaction. We're not just talking about financial losses, though those can be in the millions. We're talking about the risk of product contamination, which can lead to serious regulatory violations with agencies like the FDA. Entire batches of medicine might have to be thrown out. And then you have the insane cost of revalidating a sterile clean room environment. It's a nightmare scenario. Okay, so with the stakes being that high, it's pretty obvious that industries needed a better way. They had to evolve, right? They had to move away from just fixing things after they break to actually preventing the break from ever happening. This is a huge shift in thinking. So you have two basic philosophies. The old way was reactive, or what's grimly called run to failure. You just wait for something to break, and then you scramble to fix it. It's basically managing by crisis. But the modern, proactive approach, that's all about getting ahead of the problem. It's about predicting and preventing failures before they can cause any damage. And you can see that evolution right here on this chart. We started with corrective maintenance, that's the break-fix model. Then we got a little smarter and moved to preventative maintenance. That's kind of like changing your car's oil every 3,000 miles, whether it needs it or not. But now we've arrived at predictive maintenance, which is by far the most sophisticated approach. So what is predictive maintenance, or PDM? Well, it's not about crystal balls or guesswork. It's all about data. You have a whole network of sensors constantly taking the pulse of a machine, feeding that information to an AI that can spot the tiniest warning signs of a problem, often way before any human could ever notice. So how in the world do you know if a machine is about to fail? Well, you give it senses. You teach it how to feel, hear, and even see what's happening inside. Let's get into the amazing tech that makes this all possible. The best way to think about it is like this. If the AI system is the brain of the operation, then all the sensors are its nerves. They're spread throughout the machine, constantly sending signals back to the brain, reporting on the health of every single part. Let's start with the sense of touch, or more accurately, vibration. This little device here is a piezoelectric accelerometer. Inside is a tiny crystal, and when that crystal gets shaken, even just a little bit, it creates a tiny electrical signal. This allows the system to feel the slightest tremors, which are often the very first sign of a bearing starting to wear out. Then we have the sense of hearing. This ultrasonic sensor is basically a super-powered ear. It listens for sounds that are at frequencies way, way above what a human can hear. For example, a high-pressure gas leak makes a high-pitched hiss that's completely silent to us. But this sensor can hear it loud and clear, and pinpoint exactly where it's coming from, even in a noisy factory. And as you can see in this table, it's not just vibration and sound. We can give these machines a whole range of sensors. Temperature sensors can watch for overheating motors. Displacement sensors can detect tiny, microscopic misalignments in a massive turbine shaft. Each sensor gives us another piece of the puzzle, a unique window into the machine's health. Okay, so we have all these sensors collecting just mountains of data. But raw data on its own is pretty much useless, right? It's just noise. That's where the AI brain comes in. Its job is to turn all that noise into a clear, actionable decision. The whole workflow is actually pretty straightforward. First, the sensors collect the data, constantly. Then that raw data gets cleaned up and processed because you need good quality input. Step 3 is where the magic happens. AI models sift through all that clean data, looking for patterns and anomalies that signal a future problem. And finally, the system automatically triggers a maintenance order, based not on some random schedule, but on a real data-driven prediction. This quote really just sums it all up perfectly. Sensors are the nerves that gather data. AI is the brain that creates meaning. The nerves feel the world, and the brain makes sense of it all. It's a perfect partnership. Now, you might be thinking this is all super high-tech stuff that only exists on a factory floor. And you're right, it is. But what's really fascinating is that the same basic technology is already all around you, in the devices you use every single day. They just have a very different job to do. Let's just compare the two for a second. On one hand, you've got these industrial sensors. They are built like tanks to survive extreme heat, cold, and vibration. On the other hand, you have consumer sensors, like in your smart thermostat or your phone. They're built for comfort and convenience, usually for one specific purpose. And here's a huge difference: accountability. Industrial sensors often need something called NIST traceability. That's a fancy way of saying their measurements are certified against a national standard. Why? Well, it's crucial for legal liability. If something goes wrong, investigators need to know if the sensor was giving bad data. Your home security camera, well, it doesn't quite need that level of proof. But the core tech is way more familiar than you think. Take a device like the Air Gradient 1 air quality monitor. It uses sensors to measure things like temperature and airborne particles, very similar to what an industrial system might do. But here, the goal isn't to prevent a factory shutdown. It's to help you understand and improve the air you breathe in your own home. It's the same principle, just on a much more personal scale. And that really brings us to the big final question. We've seen this technology go from predicting massive machine failures to monitoring the air in our living rooms. So as these sensors and the AI that powers them get smaller, cheaper, and more powerful, what do you think we're going to predict next? The possibilities are pretty mind-boggling.